All right, welcome to 8.2 instructional video for Math 20-1. This is where we solve systems algebraically. You've done this before. You did this in Math 10. The main difference in Math 20 is that we're going to deal with quadratics. Now, before we get into that, we'll do that via the examples. I just want to make up a system relatively quickly here, and I want to show you the two techniques that you've already learned. And the two techniques that you've learned are substitution. I always got to spell it out in my mind there, and elimination. They are not necessarily better than each other. I would argue that substitution and elimination are situationally useful. It really depends on what question you're given. Elimination is extremely useful when one of the coefficients on the variables are exactly the same. And then it hinges on the idea you can add and subtract the entire equation. Now, that's not the case in this formula. So maybe I'll show elimination first because it's a little bit harder sometimes. What I would do is, because I have 3x plus 4y equal to 7 already, I'm going to manipulate the other equation, x plus y equals 2, so that it has the same coefficient. And the way that I do that is, if I took that top equation and multiplied it by 3, I would have 3x plus 3y is equal to 6. And the reason why that's such a big benefit now is what I could do is I could subtract the entire equations from each other. So 3x minus 3x, I'll write 0x. You wouldn't have to write that. This is the point. Because this is 0, we have eliminated one of the variables. Then 4y minus 3y is 1y, and 7 minus 6 is 1. So what I ended up with is y equals 1. Now, once I know one of the variables, I have to take that value of y and plug it into either of the two equations. I would recommend you use the easier one. So if I know that x plus 1 is equal to 2, I know that x is equal to 1. So 1 comma 1 is the solution to that systems of equations. Now, full disclosure, this is simpler than what we're going to look at in the notes. This is a linear systems of equations, and it really is grade 10 material, but I wanted to use this to kind of talk about the two different techniques you have of solving these. The other technique is substitution, and I'll probably use that one more because it's kind of my personal favorite. And the way that we need to do that is we need to isolate a variable. And it does not matter which equation you use, but use the easier one. So if I subtract x from both sides, I get that y is equal to 2 minus x. Now, what that means is that this expression 2 minus x, I can substitute it, that's the name, anywhere that I see y. And the place that I'm going to do that, it's really important that I do it, is I'm going to substitute it into the other equation in my systems of equations. So I would have 3x, but instead of 4y, I'm going to have 4 times 2 minus x in a bracket, and that's equal to 7. So I've made this substitution into my second equation in my system. And then I solve what I have. Well, this is 3x plus 4 times 2 is 8. 4 times negative x is negative 4x. Because that's equal to 7, I collect my like terms. I get 8 minus x is equal to 7. I subtract 8. I get that negative x is equal to negative 1. That means that x is equal to 1. Now, I'm not going to do what I just did again, but we would get that 1 comma 1 is a solution as well. Those are the two algebraic techniques that you're responsible for. Verification still works. It is always a good step to do. We could take, I picked this one on purpose. 1 plus 1 is 2, and 3 times 1 plus 4 times 1 is 7. So 1 comma 1 is a coordinate that exists on both of those lines, and so it's the solution to that systems of equations. We are going to look at quadratic linear or quadratic quadratic. Elimination becomes a little bit less useful in those situations, but it is still usable, and you will see me use it at least once in the upcoming examples.